everyone, and welcome to Dojo Live. Today is show number 3 of 4 in our AWS series. Of course, I'm pleased to welcome Art Chan, Senior Partner Solutions Architect, say that 10 times fast, with AWS. And he's here again with us, Art. Nice to see you.
Great seeing you again.
Yes, and then today's other special guest is Purvi Nigotia, who is Engineering Manager at Encora. Thank you for joining us, Purvi.
Hi, thanks for having me here.
It's our pleasure, and all the way from India. Purvi, what time is it for you today?
It's a bit late. It's 11:30 p.m. here.
Yeah, so she's got business on the top and pajama bottoms on the bottom, I'm guessing. Thank you so much. So perfect. What are we doing today? If you missed it, well, this is again it's a 4-part series. We're number 3 today. Our first part on AWS, we talked about why right now is really the right time to be migrating to the cloud, and of course, tips on how to get started. The second part was about containerization and when transitioning from on-prem to the cloud makes the most sense. You know, one of the things I think you coined this, Art, a term I really enjoyed from that second show was the democratization of experimentation, right? And of course, how containerization on the cloud is particularly useful for testing new workloads and load testing. So if you didn't get a chance to watch those shows, you can catch it on our website, dojo.live, keyword search AWS. But I feel like I've talked enough. So let's talk about what we're really here to talk about today. And that is another microservices architecture, serverless, right? So let's get started. First of all, what is serverless and how does this maybe differ from containerization?
Yeah, so Kim, that's a great way to start. Maybe we could take a step back and look into just the concept of compute over the years. A couple of decades ago, maybe in the late 90s, compute was largely when you have a workload, you put it on a server. The trouble with that is servers were very expensive, and you would tend to double up, triple up different services and put it all on that server into one big, what we used to call monolith. And the problem with that is whenever you had to perform maintenance on that server, you could potentially be taking down not just one service, but a number of different services in that monolith. So the move to microservices architecture is fundamental because now each of these can run in their own unit of compute. They can be separately developed, they could be separately deployed, they could be separately maintained. And the technology that kind of jump-started a lot of this was virtualization. So using that same server, you could then have virtual instances of servers within that server to run each one of these services. Now, fast forward a little bit more, we talked about containers last week, and that's a mechanism where you take those microservices running that may have been previously in a container and bundle that up into previously running in a virtual server, bundle it up into a container, and then run it in the container architecture. Now, that still requires a number of different components, including maybe a bare minimum operating system and the libraries necessary to run that service. Now, bringing us to serverless today, serverless is a mechanism where you can write code and run it in the cloud. The idea behind this is you no longer need to package this with the libraries. The cloud infrastructure, serverless infrastructure, AWS Lambda, for instance, has all the necessary libraries to run most basic languages. You can, however, customize it with a runtime to run your specific language if it's not in any of the languages that are supported out of the box. So what does this do for benefits? Well, you no longer have to even orchestrate containers anymore. You don't, even with AWS Fargate, there's an advantage where you don't have to think about your container infrastructure. This abstracts it even further. You could take your code, run it in the cloud, point your system so that, or re-architect so it's event-driven. So when you get, for example, a TCP connection coming in, you can have a serverless piece of code respond to that. You can have another event, like maybe perhaps an item that gets inserted into a queue. When that queue has a queue length of greater than 1, you can have a serverless function respond to that. So in this scenario, you only pay for the compute time of that function. There's not even a need to pay for a running container in the containerization model.
So you did mention a term here that I'm sure most of our audience is really familiar with, but that is this idea of event-driven versus what? Like a more long-term running workload? Is that?
Yeah, so in a traditional architecture, you would just have that process or that server component running all the time, waiting for those events to come in. In this case, your compute instance doesn't actually start until the event happens. So therefore, you're not paying for that compute.
So for someone like me, this would be the idea of, I don't know, I'm sitting at the stoplight and my car's idling as I wait for it to turn green. I'm wasting gas. So I'm with serverless, I'm basically turning the car off, and when it turns green, I turn it on and I go. Right?
Perfect.
Kind of like that?
That's a great example. It's, if you were to take fuel consumption as cloud spend, that would be a great analogy. Where the monolith was, you would have to have your engine humming all the time, and maybe containers could be the hybrid. And in your case, where you have on-demand engine, this is exactly what you're talking about.
That makes perfect sense. I know my sister bought a brand new Jeep, and it has that built-in function, right? And the first time that happened, they're like, "Oh my God, what's wrong with the car?" Quite funny, but it's a really great analogy. I love it. That makes perfect sense. So when we're talking about containerization, serverless, how do we know? Is there a right option for me? How can I kind of get to that conclusion?
So I think that depends, right? Like many things in life. The analogy I like to use a lot of times is golf, right? You could take a putter and you could probably hit the ball with almost any shot on the course. Is it the right tool to use for every shot? Absolutely not, right? So you have to look at your workload and be able to make that determination whether serverless is the right fit for that workload. Workloads that work very well with serverless are very short-term lived processes that can be event-driven. If you have long-running workloads, then maybe containerization or even an EC2 virtual server instance might be better for that workload. So it just takes a little bit of analysis on trying to figure out what fits the pattern. But the reality is, if you actually dissect most workloads don't live for very long. They run for a very short period of time. They do their work and they exit. And if you look at most processes, they just run in a loop, waiting for something to happen. The benefit of serverless, again, is because you're not paying for those cycles. You can deploy this on multiple regions. So if you had a need to go global with a platform like Lambda on AWS, you could push this throughout any one of our 27 regions and be live in minutes.
Wow. So Purvi, let's go back to this. I have a question. This golf club example, a putter versus a 9-iron or whatever. I'm not a golfer, driver. I don't know. Maybe you get I'm assuming we get the analogy anyway. Is there a process that you utilize to help you sort of pick your tool in terms of serverless containerization? What's some of the process that you might go through to come to that conclusion?
Right. So like Art mentioned that everything cannot fit everywhere, right? We'll have to decide based on the requirement. A very good example, which I can give you from my experiences, is that if a client is planning to put their monolithic application or a legacy application to cloud, having a container might be a good idea. They don't want to restructure their code or don't want to spend too much time in rewriting everything. You just pick it up and put it in cloud. But at the same time, when we are building something, and like already said here, that almost everything can be executed on serverless. I do agree that. So if you are doing it from scratch, you're trying to refactor your code, writing it again, why not to go with something which is more lightweight, easy to scale up? Usually in those cases, we prefer going for serverless. We know that we don't want to get involved into managing the servers. Just write the code and deploy it so it's ready for usage.
Right. And going back to our previous example, I suppose it's sort of like, okay, I can do some modifications to my existing car and make it more fuel efficient, or I can buy a brand new one that's going to cut off the fuel of the ignition or whatever it is when I'm at the stoplight, right? Perfect. Cool. So let's get in. You already touched on these, Art, but let's get into more of these sort of upsides of serverless. Like, what else? What else benefits does this bring?
Yeah, so unlike running a virtual server or even a container, you no longer have to worry about patching the underlying infrastructure. You no longer have to, I mean, even with containers, as much as you don't have to manage patching servers, you still have to keep all the dependencies up to date with security patches. So there is an integration component of running containers that you still have to manage, albeit significantly less than a virtual server. Now with serverless, that is abstracted away from you, and the development aspects is rather streamlined. So you can use our serverless development tools like SAM to do serverless development. You can test these functions locally on your development systems, and then push them out to the service AWS Lambda when you're ready to go. Load balancers can be set up just the same way you would with containerized workloads or virtual server workloads, so that when you're servicing incoming requests, they get routed to a serverless instance instead of a physical server or container.
Very, very cool. Awesome. Let's talk a bit more about this too. You said something about being available in, I think, 27 countries and the ability to run in a variety of regions almost instantly. I think that's extremely impressive. Perhaps we can dive into that a bit deeper. And Purvi, maybe if you have any examples of when you've been able to apply that in real life.
Sure. I think I have done a lot of projects in multiple domains where we have built enterprise level architecture using serverless. One very good example is from one of the fintech projects that I did. So we did the entire implementation using serverless microservices, and the beauty of that project was that it has something called multi-tenancy and single tenancy, where clients want to keep certain services shared while others as dedicated to their customers. So by using these serverless microservices, we were easily able to provide that kind of architecture. Plus, like we know that this AWS Lambda scales up very quickly. So initially, it was structured for a certain number of users, but then they decided, no, we are good to open it up for a huge number of users, let's say. So it came well without making any changes to the architecture. Serverless was able to cater more number of resources. It scaled up well within milliseconds. So that was one of the best architectures we did for enterprise level. There was another one for one of the e-commerce application where the platform was existing, so we did some headless on top of the existing one. That was purely to enhance the performance. So these are some examples where at one place the person wants to rewrite the entire thing, do the entire architecture. The other place, they don't want to move out from their legacy application, but they want to enhance the performance. So go for headless, sitting on top of your legacy application, providing you a better user experiences.
Perfect. How about you, Art? Do you have any other kind of examples of this? I think the right word is portability.
Yeah, so AWS has a number of public case studies, a number of which you'll find on our websites. But Lambda at the edge, or serverless at the edge, is a very frequent use case. And this kind of ties and marries the two concepts of serverless and bringing the compute as close to the customer as possible. The reason that you want to do this is because of compute latency, right? Obviously, traversing the network, even at near speed of light, does take some amount of milliseconds, right? And compound that with internet traffic and crossing undersea cables and different routing points. a lot of times, if you were to centrally process dynamic compute, so things like authentication or anything that requires user responsiveness from a remote location, it's a perfect example of where you could take that compute, move it out to the edge nodes in any one of our regions, and then have the user routed to that service through geolocation services. And we could talk about, how that works with dynamic DNS, where based on the user's request, we can route them and give them an address response to, in this case, a Lambda process that's closest to them, so that the response and the latency would be minimized.
Mm-hmm. I think for me, and one of the biggest use cases in real life that come to my mind would be like streaming. I mean, you've got a variety of different service providers of this, right? Big ones, Netflix, Amazon Prime, Disney Plus. This is an instance in which serverless is applied. Or in terms of the portability, me getting access to what I want, when I want, near instantaneously from a huge potential catalog, which also is divided into regions, right? I mean, I'm living here in Mexico, and I know a lot of like the content that I'm able to access is not the same content that's, being accessed from the United States or elsewhere, and vice versa. Am I sort of on the right track here?
Yeah, I'd probably take your first part, and that part is real, right? 10 years ago, you click on a web page, you didn't have an expectation that you would get a response back right away, right? Today, when you go, especially with just the last week of Black Friday shopping, when you click on a website, you expect all the content to load up at once, and
if it doesn't, you're gone.
Changing.
And I think that's the point of why this
Exactly.
is necessary, right? Yeah.
Right. And the folks here at Amazon have done analytics, and they show that you can lose a user or lose a customer if the content wasn't loaded and perhaps some time constraint. So it's very important to have that low latency in addition to all the other benefits of this architecture.
I love it. Thank you. Cool. So when it comes to, I think, microservices in general, correct me if I'm wrong, it's probably with containerization or serverless, we do have this particular DevOps role that's sort of coming into play. What is the DevOps in this element, and how is this coming together?
Yeah, that's a great question. Maybe Prithvi can answer that on behalf of some of Encora's customers, but I know that this is all integrated. It all comes from the DevOps world, right? In DevOps, not only do you want stable releases that we all expect and want, but DevOps encompasses a number of different things, right? You want to have your infrastructure no longer represented as no longer a number of operations guys, jockeying on the keyboard, perhaps making mistakes. You want to be able to define it in code, and being able to push that code and magically have infrastructure appear is the ultimate goal, because the ops guys can now borrow from the development best practices. Things like code reviews. You can review your infrastructure through code reviews. You can have multiple eyes on it, and you can also have change management, like you do in not the change management from 10 years ago, where you log something but the operator does something different. You actually have real deal revisions. Your infrastructure's as code. You could check in that code, you could check out that code, and know exactly what happened, not what somebody reported to happen. So I think the DevOps ties this all together, because with DevOps, you can not only deploy, it's not an either or, right? It's not a virtual server or a container or serverless. DevOps ties them all together in a mechanism where you can define a very complex infrastructure, maybe picking one or more of these components together and deploying it in one coherent mechanism.
Yeah, like the mechanism that's making it all happen. That's absolutely fascinating, and definitely seems like a space in which there's going to be a lot of relevance and a lot of changes, I think, upcoming in the next few years. Matter of fact, I think we are going to be talking about that much more in depth in the fourth segment and final segment, right, of our AWS series here on dojolive about DevOps in particular and focusing on IAC leveraging and cloud formation. I think you already mentioned this, the CDK. But when we're wrapping up today, I think I would like to bring it back to you, Purvi, and your experience, and just like I think Art has laid out this last decade, right? This last 10 years, as a leader, what have you seen sort of shifting in this sphere in your particular role? Maybe how have you had to adjust, or do you have any sort of tips or advice, for other people in your role or who are coming into a role like yours on sort of how to handle all of these amazing changes?
Sure. So I think I'm in industry for past 12 years and I've seen a lot of shift. I know Art must have seen much more than that. But within that itself, like when I started, it was like a Java backend developer working on on-premises things. And now it's cloud. And once I got into the cloud, this infinite cloud is so much to explore. The biggest shift that I have seen is obviously the last part which you talked about, DevOps, because now the developers and operations works very closely. So you cannot isolate the development from how it has to be deployed. Again, automation is key everywhere now. Everyone wants to deploy the code within a click. So that is one of the things. The other thing is that now you have a lot of there are a lot of services provided by cloud. You have maybe you can do hybrid models. You cannot rely on just one kind of architecture, that today I'll select serverless and my entire project sits on serverless. There's an opportunity to club container with serverless. So the thinking has to be broadened in that fashion. So those are the kind of shifts that I have seen, and like I said, there's a lot more to explore.
I bet. Like you personally, or Art as well, if you guys have suggestions, what have you done in terms of keeping up? How do you kind of achieve this education, this continued education to stay competitive, the top of your game, individually, and also what type of support do you sort of see with the companies that you work with and for to help you do so? I mean, in terms of Amazon and Encora, what has that looked like as individuals in keeping up, sharpening your skill set continuously?
I think that's no different than any other evolution. With technology, I mean, we live it day in, day out with our customers, and we see the limitations with different technologies. I mean, we saw the limitations from monolithic server installations before, and when we moved to virtualization, there was a number of challenges, and hundreds of companies get founded to solve these problems, and you just take a step back and you say, wow, if you could fundamentally change the architecture, you would get rid of all these problems. So when new technologies come out, it's very evident to many of us that, hey, this really solves a problem. This would streamline things and make things more efficient. And I think we hit the nail on the head. I think it's not just the migration to the cloud, the containerization, the serverless components, the microservices. It's everything, including the DevOps, which we'll be talking about in the next conversation.
Yeah, for sure. And the ability to embrace change, which is so hard, especially, at least for me, my personality type, which is why I'm always in awe of individuals like yourselves who are just like, yes, like, let's keep up. What's the next great thing? It's absolutely fantastic. Purvi, how about you? What can you speak to that?
I think almost in line with what Art mentioned here, but yeah, along with that, reading more about what's new in market, getting updated. In case of AWS, I can say certifications are pretty helpful. I mean, because I have done one of them recently, I'm looking forward for more. So these are one of the, paths that help us to grow, explore more what's available.
Perfect. I think that's important that, Amazon themselves, AWS is continuously, I think, creating content and the teachability, and then having employers and places that you work allowing, right, and making space and encouraging individuals to keep up, right? And I think that's a really, really, really important and integral part of technology today. Amazing. So, we've actually kind of come to the end of our kind of half hour today. Any final sort of words of wisdom from either one of you in terms of serverless or just your entire cloud journey as we wrap up today?
Yeah, so this is also coincidentally reInvent Week. This is AWS's largest conference of the year. It's happening right now in Las Vegas, and there's free virtual attendance. So to kind of dovetail into your last question about learning about new technologies and developments, I'd encourage everybody to sign in and take a look at some of the talks that's going on right this moment.
All right, that's great. And I believe that's happening in Las Vegas, and Encora is actually present there as well. So you can find Encora at reInvent Las Vegas if you happen to be there in person. And what's the best way to get a hold of those free sessions? Is just Google AWS reInvent or?
Yeah, AWS events. At AWS events, you'll see the reInvent link. There's a sign in and there's free virtual attendance. So encourage everybody to take a peek at it when you get a chance. There's lots of new announcements that was made yesterday, today, and I expect a few more in the next couple of days. So stay tuned. AWS is always innovating for our customers, and we're expecting to see a lot more neat things come out of it.
Perfect. Well, thank you, Art, in particular, for joining us on what I imagine to be an extremely busy week for you and your team. It's our pleasure to learn with you and from you today, as always. Purvi, thank you so much for sharing your knowledge and your experience with us as well. The next and fourth and final segment of our AWS series is going to be happening on Wednesday, December 14th. Again, 10 o'clock Pacific. You're going to want to watch that one, especially if you're interested in DevOps. That's what it's going to be about. Thank you again, everyone, and stay safe. Bye for now.
Bye.